My name's Martin Beeby. Has anyone got a camera phone? Anyone got a phone? I'd like to take a picture. Would you do me a favour? And this next slide is quite important to me. It's called my Inception slide. This is me standing in front of a slide of me, standing in front of a slide of me, standing in front of a slide of me, standing in front of a slide. It's 21 levels deep. And that was me 5 minutes ago in the last session. So by the end of this day, I should be 22 levels deep, I think, in my Inception slide. So if you could send that to me somehow, that would be great. Oh, you're going to take a note? Right, okay, cool. So I'm, by the way, I've missed it. I've lost it. Never mind. We see. I'm a software developer. I've been a software developer since I was 16 years old. And I've been a developer for over 20 years. I worked at Microsoft for 8 years, Oracle for 1, and then I joined AWS as a principal .NET Evangelist. And I talk about .NET around the world, explaining the .NET support and also Windows support on AWS and how you can, as Windows and .NET developers, take advantage of AWS. I came to AWS not really knowing very much about what you could do with Windows and with .NET and with Microsoft technologies. And over the last 8 months that I've worked here, it's been quite a journey of discovering just how much support they have for .NET and how much support they have for across all of their services. And so what I want to do over the next 50 minutes is kind of show you what I've learned in the last in the last 8 months as a .NET developer, which is kind of came as new to AWS. So AWS has been doing Windows technologies on AWS since 2008, when we introduced our first instance types of Windows. So the first time you could create a Windows server was effectively in 2008. And since that time, over nearly 11 years, they've constantly incremented and added new features for Windows developers, for Windows people, not just developers, for Windows infrastructure people as well. And in the last session, I talked about our PowerShell support and showed how much that's improved over the last few years and the things that you can do inside of PowerShell for AWS. And I've also talked about, for every kind of thing that you can do in the .NET world, there is some way of doing that inside of AWS. And I think for a lot of .NET developers, they don't always immediately think of AWS when they think of a cloud provider for them. They might think of another, I can't think who, but they might think of another provider. But actually, AWS has got a lot of support, and we've been doing it for a very long time. We've been doing this for over 11 years. So we've got really great support, and we try to find and speak to developers and .NET developers and find the places where they're having trouble or they're trying to improve. And we look at what they're doing and see how we can make their experience better. So we're constantly innovating. That was on the Windows instance types. There's tons of different releases that we've had over the last 11 years. Now we have EC2 for Server 2019, and we've got great support for SQL Server as well. Whether you want to run your SQL Server on your own EC2 instances and manage all of that yourself, or whether you want to use RDS, which is the relational database server, which is giving you SQL Server as a service. We create it across 2 availability zones and make it very easy for you to use within your application. So this mic's really noisy, I apologize. So it gives you, there's lots of ways that you can build or run SQL Server. And you'll see that we're constantly adding updates around the kinds of SQL Server we support, the instance types that can run SQL Server to give you better and better experiences. For .NET, we have lots of new advancements. I've talked about the PowerShell tools to enable that. We had the SDK originally in 2008, so the ability to create AWS infrastructure from .NET code, from C#, F#, Visual Basic. And then all the way up to modern things that we're doing, things like Lambda support, which we added up in sort of 2015, 16 time frame. We now have a new .NET Developer Hub where you can go and find out all the sort of specific developer documentation specifically for .NET developers. We have some SDKs like the AWS X-Ray.NET Core. So AWS X-Ray is a service, and they have a sort of specific .NET SDK just for that one service, which allows you to instrument your applications. we're constantly adding things for the Windows developer. And also there's things like the app modernization. So whether or not you want to use Windows deep learning, we have instance types for that. We have Lambda support for not only .NET Core, but also for PowerShell Core too. We support .NET Core. We have instance types to run .NET Core. We have all sorts of things for the modern .NET developer. And whatever kind of application you want to run, you can run it here. We have customers over the last 11 years which have been running Windows applications at huge scale. Actually, of all the customers in the market which are running Windows, 57% of them are running on AWS. So we have the sort of market share of Windows workloads. So we have a lot of experience going back 11 years. We have experience of scalability. And we also have features which developers are asking us and infrastructure people are asking us to support on the Windows and .NET platform. So as an AWS user, you might be thinking, well, how could I create infrastructure? Of course, there's a number of different ways you could create infrastructure or use things inside your application. We could use the AWS console and go in there and start creating stuff. That's the Lambda console. We've got command line interfaces, which we can go and create things like S3 buckets directly from within, from the command line. We could use PowerShell if we're an infrastructure person on Windows and we want to use PowerShell. We have complete support of PowerShell, and I spoke about that at length in the last session. We have support for a thing called the Toolkit for Visual Studio Code. This works more for serverless applications, but if you're using the IDE, the Visual Studio Toolkit, Visual Studio IDE, Visual Studio Code IDE, then you can download this as an extension. And predominantly that extension supports serverless applications at the moment, predominantly. But you can build .NET applications inside of VS Code and even deploy them directly from VS Code to AWS. And that's available in preview at the moment. You can download it from the marketplace as an extension, install it into VS Code, configure your profile, and away you go. You can start building serverless applications, .NET Core in VS Code. But most .NET developers that I speak to don't really use any of those options. What they want is an integrated environment into their CI/CD pipeline. So maybe that's Azure DevOps, or maybe it's their on-premise TFS server, or maybe it's it's an AWS code build. So they want that kind of experience so that they can deploy stuff and it goes through a code pipeline. And we support all three of those things. We support Azure DevOps, so you can deploy stuff from Azure DevOps into AWS. From your TFS servers on-premise, we have extensions which allow you to publish directly to AWS and create infrastructure in AWS. But developers, fundamentally, they like to sometimes experiment or to create directly inside of the tooling that they use. And for most .NET developers, that's Visual Studio. And so I'll be doing the rest of this talk in Visual Studio and showing you what sort of support we have for the .NET developer in AWS inside of Visual Studio. So the first thing you'll want to do if you're using Visual Studio is to install the AWS toolkit for Visual Studio. And to get that, you're going to need to get a V6 template, a V6 extension. I thought it was called a Visix extension until a few weeks ago when someone corrected me. It's a V6 extension. And to get one of those, you go to the Microsoft marketplace for Visual Studio. We upload pretty much every day. We have a release of our toolkit, and we're constantly updating it. So if you go to our toolkit, go to the extensions for Visual Studio website, just search in AWS. If you search that, it'll bring you back a number of different tools for AWS, but the top one will be the AWS Toolkit for Visual Studio. It's had 1.2 million installations. It supports 2017 and 2019. We also have versions that support 2013, 2015. You download the V6 template installation extension, and once you've got that, you click it. It guides you through a wizard. You'll need to close down Visual Studio, but it will install the Visual Studio tooling for you. You install that, and what that lights up for us inside of Visual Studio is a thing called the AWS Explorer. And the AWS Explorer allows us to start creating stuff inside of AWS. So to find the AWS Explorer, we go up into the View menu, and we go over to AWS Explorer. That will open up a little tab called the AWS Explorer. We can choose which profile we want to use. Default, I've got two, default and work. We can add profiles for different accounts or for different, how we're working. These are the same profiles that you would set up for your CLI, and if you've already set them up, it will find them. Once we've created a profile, we can choose the region up the top there. So I'm in EU Ireland there. And then we can look at the services. So this is DynamoDB. Now, from within Visual Studio, I'm able to interact with dynamodb. I can create attributes on a table, on a document, on dynamodb. So we can add name. I've got a thing now saying name and a thing called Jeff. So I can put a name in there as Martin. And whether that guy's a Jeff or not, no, Martin is not Jeff, so no. I could commit that to dynamodb. I can add another person, Jeff. Is that a Jeff? Yes or no? Yes, not using booleans here, just using strings like any professional developer would obviously do. Commit that to my DynamoDB. I can add an attribute to my DynamoDB table. So age for the two users. So Jeff, first. We'll call him 35 years old. And Martin, obviously I'm 21, so put that 21 in. I wished. Commit that change to our table. So what you can see is I can add and update, interact with a service from within Visual Studio. I can also scan a table, which is a search. So I could say match name where as a string where it's equal to whatever I put in here. So if I put in a name like Jeff, it should return one row when I scan the table. Now I'm not suggesting you do manage your database like this, but this is one way that you could or you can interact with data from within Visual Studio. So I can say contains JE. It returns just that one row as well because it's doing a partial search or a partial scan. And I can interact with all sorts of instances. I can create EC2 instances directly from Visual Studio, RDS, I could do CloudFormation. I could even set up a user. So I could create a brand new user from within the tooling to work on my application. Put Jeff in there, and then I can work on his security groups and what he has access to in my account, access keys and policies, all from within Visual Studio. You don't have to ever leave necessarily. And obviously this is working live against your AWS account. So any changes I make here are going to be available in all of the other methods. I'll see it in the CLI, I'll see it in the console, but my preferred method is working from Visual Studio. Now we cover, on the left-hand side, we cover a number of different services. You see you've got CloudFront, DynamoDB, EC2, Elastic Container Service, RDS, S3, SimpleDB, SNS, SQS. SQS is like a queuing service. We can add items to our queues. We can delete them all from within Visual Studio. CloudFormation, so we could create more complicated infrastructure, deploy it, and then watch the logs come out all from within Visual Studio. Elastic Beanstalk and various other things, or AWS Lambda. We also have a number of different features inside of file templates. So when we do file new now, we're going to have lots of AWS templates that we can choose from. Now, when I came and joined AWS, the first thing I wanted to do was I'm going to take a .NET application and I want to deploy it to AWS. What's the simplest way for me to do that? And I would say the simplest way for an idiot like me to do that was to go, hey, I'll use Elastic Beanstalk, because it's of all the AWS services, I have to do the least to get this to run. So I thought that sounds like something I'm even capable of. So I started thinking about using Elastic Beanstalk. And the cool thing is with Elastic Beanstalk, it's very, very integrated into Visual Studio. So we can just build a brand new, any ASP.NET application, whether that be ASP.NET Core or ASP.NET 2 or ASP.NET Full Framework or Full Fat, as I like to call it. Any .NET application could be deployed to Elastic Beanstalk. So I can create any of those applications, right-click on the project type, deploy to Elastic Beanstalk, and that's what we'll do in the next section. So if we just go to Visual Studio and go to File, New Project, we have the ability, this is VS 2019, by the way, if you're not familiar with the File New Project here, but if I type in AWS, it shows me all of the templates for AWS project types. So I've got lots of Lambda stuff in there and various blueprints to get me started. But I'm just going to start with a standard .NET Core web application. I'll call it Web Application 6. Why not? We create this thing. And what that will do is then we can choose what type we want. I won't choose empty. Empty's never empty, I always find, which is web application. It will create an MVC application for us. And it's just a sample .NET MVC application. Nothing special about it. But now, because it's a web application, I can right-click, and I've got this new option to publish to AWS Elastic Beanstalk. And it's giving me an option to then create a new application or deploy to an existing one. I've not got one, so I'm just going to choose a new one. I'm going to give it an environment, so I'm going to call this the dev environment. And then I'm going to go and check availability of that URL, which it generates for me. And I'm going to give it some ideas about the container type and the instance type. So I'm going to run my application inside of a 64-bit Windows Server 2016 running IIS 10. And I'm going to use it on an instance type of T2 Micro. I'm going to add a key pair. This is useful. This key pair is the security key, which is going to allow me to get access to these instances if I ever need it. So I'm going to create a key called VS key. And click Next. I'm going to deploy a user role, an IAM role, which gives me the security context, and then various other build options, which I'm going to ignore, and just click Next, Next, Deploy. What this is going to do is it's going to take my application, it's going to package it all up, and it's going to deploy it to AWS for me. Now, what packaging up means is it does a .NET build, so it runs whatever we would ordinarily build. It takes the artifacts from the release folder, it packages them up in a zip file, it adds some config files for Beanstalk, which are the things you've set up in that wizard, and deploys it. Everything you're doing from inside Visual Studio is executing CLI commands. There's nothing we're doing here inside of Visual Studio which you couldn't just go down into the command line and do. That's really important because this is just a pretty picture on top of the SDK or the command lines. And that's important because it means that everything you do with inside of Visual Studio, you could absolutely do in a build and release pipeline. Like nothing, just because we're doing it like really sloppily here directly from our environment, does not mean that you couldn't just do this, and we probably should do this from a pipeline, a release build. So once that's installed and ready, it will say inside of Visual Studio, look, give you a URL, you can click on that URL, and you'll see it's a .NET application. It's got MVC, it's got routing, it's got everything. There's no changes I've had to make to get that working or running. And even because I've got some instances here, I've got one instance, I can actually connect to it, but I can't connect to it because port 3389 is by default switched off. So if I try and connect via remote desktop, it's not going to allow it. So what I want to be able to do is open port 3389 on that machine, which I've added to Elastic Beanstalk. Now in AWS, ports, firewall rules are controlled by what we call security groups. So we need to go into the security group which manages that instance and set port 339 to being open. Then we will be able to connect via RDC. In this Elastic Beanstalk instance, I've created one instance and no load balancer. I could have easily created 3 instances with a load balancer, and I would have 3 instances here. But in this demo, I've only got 1 instance. So what I can go is into the AWS Explorer, go over to EC2, go over to the security groups, find the security group which is attached to the Elastic Beanstalk instances, and then I will add a permission for RDP. So down at the bottom there, RDP, it will add port 3389 to my security group, and then all of the instances which are managed by that Elastic Beanstalk environment will now accept incoming and outbound on 3389. So this would be how you'd set up specific ports for that if you needed to do that manually. So now once we've got that set up, what that means that I can, from within Visual Studio again, I can click Connect to Instance, and I can, because I have the credentials, the EC2 pair credentials, it will just automatically RDP into that machine for me. And the reason I'm RDPing in this machine is not suggesting that you should do this to your production systems, but just to show you that it is just Windows. We're not running anything special. It's Windows, it's 2016 with IIS 10, which we're deploying to. Elastic Beanstalk is just a deployment mechanism to a cluster management system for Windows servers or Linux servers. And so it's a very easy and simple and straightforward way to get started. And it's just a deployment directly to IIS. It will set up things like load balancers for you and various other things, which is cool. So what I've got is I've built an application which I'll show in a second. It allows to sort of vote, and it was a bit more of a complicated Elastic Beanstalk application. So I took a very simple one there and published it. That worked very straightforward. But what happens if you need multiple instances, a load balancer, maybe you need Redis, a few other AWS services? How do we build something a little bit more complicated? Well, This is my application. It's a quite straightforward SignalR application, which is a real-time framework in .NET. And it has a function which is called send response. And what this piece of code does is that when you vote in the application, it will send a response to my application. And my application will take that response, and in the add response thing, I'm using the SDK for X-ray to log all of my interactions in this function. You'll see that if I get any exceptions, I'm logging it to X-ray as well. This is just a NuGet package which I've added to my application. And then I will take whatever someone passes into this application, I'm going to just store it in dynamodb. So I'm going to load a table called question responses, and I'm just going to, whatever you respond to in this application, I'm just going to store it directly in dynamodb. So in that function, I'm using 2 different AWS services. They're all just NuGet packages. It's all .NET. It's all straightforward stuff. So if I publish that application to Elastic Beanstalk, I already have an instance or an application environment. So I'm just going to redeploy it to that environment. And what that's going to create for me once I've deployed it is this infrastructure. I have got a presenter, which is me, and users, which would be you, calling into an Elastic a load balancer, which is then routing you to 2 different machines. So let's have a little look at the actual application. Excuse that. That was me getting my picture from the last session. Someone sent it to me on Facebook. A bit risky putting it on Facebook, isn't it? Let me have a look over here. Oh, actually, I've got it over here. .NET voting. So if you go to that website, if you've got an iPhone, or I'm sure it works on Android as well, if you just scan that QR code, so the camera application, it will take you to the URL, thebeebs.org/present. And it takes you to a website called voting.thebeebs.org. And, oops, it shouldn't say that. What it should say on your phone, it should say, please wait. So if is anyone there yet? Cool, there's a couple of you got your hands up there. So it's got like a please wait signal over there. Now, what happens is when I change what's on my screen, that sends a SignalR request to my server, which then should update all of your phones with and provide you with 2 questions, like 2 choices. And so then you will vote in this application, and then it will go through, when you vote, it will go through that little function we saw. So it's storing that stuff in X-ray, it's logging stuff in X-ray, and then it's storing my information in DynamoDB. And boom, so vote, coffee or beer? There's more coffee. More people want coffee today than they do beer. That's a very healthy audience, I think, although beer's catching up. I've got tea, actually. I should have put that as an option. Maybe a slightly more contentious one. We'll see. Tabs or spaces? And you'll see as I changed the presentation, it updated the slides. As you're interacting with your applications, it's sending real-time WebSocket requests to my application. So it seems that spaces is more impressive than tabs in the Ukraine. That's interesting. Right, so when I first deployed this application to Elastic Beanstalk, I had a bit of a problem in that this load balancer would route any user to either one of these 2 applications. And when we're using SignalR, SignalR is under the hood using WebSockets. And WebSockets require a persistent connection between server and client to be open. Really lightweight, persistent connection. And that's how SignalR works. So if it's routing you to different servers, there'll be problems about where messages get lost. Also, the presenter connects to one server. If I change the slide or the questions will only get updated for the users which are also connected to that same server, because this server is not getting any messages from this other server. So there's 2 things I had to do. One, the Elastic Load Balancer. I configured that to use sticky sessions. So what that means is that when you join as a user or a presenter, it assigns you to a server automatically, and the next time you visit this application, it takes you back to that server for a period of about an hour. So it will always force you to the same server. So that means that if we establish a WebSocket communication, that's going to work. Good. Now we need to fix the two machines talking to each other. And this isn't an AWS or an Elastic Beanstalk problem. This is a SignalR problem. In SignalR, when we have multiple instances, which are managing our application, and we want to pass messages between them, we need to use a thing called a backplane. A backplane is implemented in Redis. Very simple to do in SignalR. You take a Redis cluster, and you connect it with a couple of lines of code to your cluster, and SignalR will just work. In AWS, we have a managed service for Redis. It's called Elasticache for Redis, and we will, it's a high availability Redis service. So I created one of those very quickly, and then in my application, I added the following. So I went to configure services of my .NET application, and in this bit in production, instead of just saying services.add SignalR, what I did is configured Redis for this SignalR application. So add stack exchange Redis. I provided the connection string. Now this is the connection string to my Elasticache Redis, which is dev days blah, blah, blah. So I added that connection string to this to here. And then also I passed over a few options. Usually in a Redis cluster, you will have multi-channels. Each application will use its own channel. So I'm just going to add this to having a channel, its own channel, which it's going to communicate on. Give that a channel prefix of voting app. And then this Redis cluster could be used by multiple applications, but only messages passed to voting app are going to be distributed via SignalR. Those 4 lines of code is all you need to do in SignalR to set up a backplane using Redis. So now, when the application that you saw and you used was using, I think, 3 instances, because I like it to be able to scale a little bit for these sorts of events. And when you were communicating, every message that you sent got routed back via Redis to the other instances. So if you've got complicated scenarios, you can do that all within Elastic Beanstalk, and that's kind of what I was showing to demonstrate there. It's not just a file new, simple website hosting. You can configure all of it to do whatever you need to do. And so Elastic Beanstalk is a great way of storing and using, of building and taking existing .NET applications and hosting them. It's particularly good for, let's say, legacy .NET applications. Because it's just IIS, you can choose the version of IIS you want to deploy to, and it will work. You can guarantee that it will work. But if you want to do something a little bit more modern, maybe you wanted to think about how to containerize your .NET application. Well, we have a number of different ways of containerizing applications in AWS. And from inside Visual Studio, we can very easily take our .NET application, put it inside of a container, and then publish that to AWS. And so in Visual Studio, I'm going to right-click that same project, and I'm going to add a Docker file to this project. Now, Visual Studio has a way of adding a Docker file. So we go add Docker support to this application. I choose if I want it to be a Linux or a Windows Docker container. I'm going to choose Linux. What that will do is add a Docker file to my application. And if I click on that Docker file, it will have a multi-stage Docker build. So it takes my .NET Core application, it deploys it exposes port 80 and port 443. And now I have a new ability to publish container to AWS. Just by that Docker support file being there, it lights up this feature. And I can publish it directly to ECS, or what I'm going to probably do here now is publish it to as an image to the Amazon Elastic Container Registry. So this is like if you've heard of Docker Hub, it's a place where you can put your Docker images so that you can publicly use them somewhere else. So if I was a developer, I would probably be deploying to a registry my container so that then someone could take that Docker image and deploy it to production, or run tests on it in testing or whatever. So once I've got it in a container registry, I could then deploy it on AWS. I've got this Docker image. I could download that Docker image. I could run it on my machine using Docker. It's just a Docker image, right? But then I've got an option. Like, where do I go and run this in AWS? So there are a number of places you can run it, and depending on the type of application, .NET application you've got, there are a few options. So the first one would be Amazon ECS. And you can run any kind of .NET application in here because ECS supports Docker for Windows as well as Docker Linux containers. So if you were to say there, if we'd have added a Docker file and said, build this as a Windows Docker image, it would use Docker for Windows, and it would create a Windows container. Now, Windows containers are bigger than, say, a Linux container using .NET Core. But sometimes if you've got an older application which is running ASP.NET 2 or ASP.NET 3.5 or something like that, you need Windows. It won't run. It's not cross-platform, so it won't run on Linux. So you can build a Windows Docker container. You could deploy that to Amazon's container registry. And then we could take that and run it inside of ECS. ECS is our Amazon Elastic Container Service. What you're going to have to do here is create a cluster. So you're going to have to create some infrastructure. You go to you can do this through PowerShell, or you could do it through the command line, or you could do it through the console. Create a new cluster, choose how many machines are going to be in your cluster, and then we can then just take those Docker images and we can deploy them to ECS to that cluster of images. But you have to manage the infrastructure somewhat when you do that. You have to create the infrastructure and manage it. If you don't want to use Amazon Elastic Container Service, or maybe you've got existing investment in Kubernetes, we also have a managed service for Kubernetes. It's Amazon Elastic Container Service for Kubernetes. It's a highly available, scalable, and secure Kubernetes service. And again, you're going to have to create your initial Kubernetes cluster and manage that cluster yourself. But we have support for .NET Core on Linux, so you can use Linux containers. Obviously, you can use Linux containers on any of these container platforms. And we also have a preview of running Docker for Windows containers on EKS as well. So you could run Windows. In both of these scenarios, we could run Windows or Windows images, so .NET on Windows, or we could run .NET on Linux in both of these containerized environments. There's a third option which is only available if you're targeting Linux, and that's called Fargate. And Fargate is actually built on top of ECS. And the difference is that instead of creating the kind of cluster and managing the cluster effectively, which you have to do with ECS, we create a cluster for you with Fargate. We create an ECS cluster for you in our cloud, in our section of the cloud, and then you kind of give us your container, and we run it over on our cluster. So we manage the cluster. We make sure that how many images and stuff, how many machines and stuff. That's all for you. It's kind of like abstracted. You give us your container. We run your container for you, and it's all good. At the moment, that only supports .NET Core on Linux. So you have to have a Docker Linux container to be able to do that. So what I just did there, that would definitely work on Fargate if I wanted to do it, because as far as Fargate is concerned, it's just a Linux application. It's just a Linux container. So that's how you could build container applications for .NET and run them. But let's look at another way of running .NET, which is serverless. So I wanted to try and create a demo which wasn't like super simple. So I thought about like answering a big question. And I thought I'd use lambda to answer, or serverless to answer this following question: the meaning of life, the universe, and everything. Now, I don't know how famous what I'm about to reference is in the Ukraine, but there's a book which answers this very question. It's called The Hitchhiker's Guide to the Galaxy. Is anyone familiar with this? There's a couple of people, good. And in The Hitchhiker's Guide to the Galaxy, the almighty answer to the meaning of life, the universe, and everything was calculated by a computer, deep thought, for 7 million years. And the answer, the almighty answer, is 42. Just 42, that's the answer. So I thought I'd create a lambda which did exactly that. So we go into File, File New, Project, and now you see like the project templates that I can choose from. I choose AWS Lambda, press OK. I'm going to choose a blueprint, just an empty function. It's not empty, it's got stuff in it, but it's pretty empty. It contains like a default handler, which is going to do some really basic, it does like a two-upper. So kind of useless. All it does is take the input and it echoes it back out, but it capitalizes it, right? That's what it does by default. We need something more complicated, right? So I'll implement my complicated algorithm for the meaning of life. It's actually harder for me to write a string than it is. Yeah, there you go. So implemented, checked in, artificial intelligence. There we go. We can use a thing called the mock lambda test tool in Visual Studio, which is a tool that we've created to allow you to test serverless applications locally. So you can do this on a train or an aeroplane with no Wi-Fi. And we can give that function an input. What is the meaning of life? Question mark. We can execute that, and we'll get an output, and the output is 42. But we probably don't want to just leave that function, that amazing function, just on our machines. We want the whole world to be able to see it. So to make that possible, we have to go and deploy it. So inside of Visual Studio, we can right-click our application, and because it's a serverless application, we now get a new option saying Publish to Lambda. We click on that. We support .NET Core 2.1 and .NET Core 1 in Lambda. We'll call this function 42. Click on Next. Give this an IAM role, which is the security execute, like the role, the security execution that it's going to run under. So give that an IAM role, upload it. And this is going to give that function, that IAM role is going to give the function ability to access other AWS services. Our function doesn't really need very many other AWS services, but if I was calling like recognition or another service, I would need to make sure that that IAM role had those permissions. And I deploy it. And what should happen is that then that's, you can see it's just doing a .NET build. It's packaged it into a zip file, and then it uploads it. And now we can go from within Visual Studio, what is the meaning of life? We can invoke it from Visual Studio, and then it invokes that function in the cloud and responds with 42. But now because it's in the cloud, we can see things like the logs. So we can see that it's got a duration of 0.36 milliseconds, and we've been billed for 100 milliseconds of execution time. We bill Lambda for every a minimum of 100 milliseconds. That's the minimum sort of bill. So it's not per second billing, it's per 100 millisecond billing of execution. And you only pay for the execution of your function. You don't pay for any hosting or anything else. So we're paid here for 100 milliseconds worth of execution. Our application used 82 megabytes of memory, and the maximum memory that it could have used was 256. So we can see our function worked. We returned 42 within 0.36 milliseconds, which is good. In Lambda, we have a feature called Lambda layers. Lambda layers, you're allowed to add 5 layers to a Lambda. Layers are like, the way I think about it is like other references that you can add to a function. So you can have up to 5 of these references. The way that they are is just like pre-built zip files, effectively, which get compiled with your zip file that you upload, and then that creates a completed function or completed Lambda. And this is useful in the .NET world if you want to cache like NuGet. If you have a number of NuGet packages, you could put them NuGet packages into a Lambda layer, and then you can reference it from multiple Lambdas. And that way, every time you iterate and update your Lambda, you wouldn't have to upload alongside it all of the NuGet packages which support that Lambda function. So a number of people use this feature for NuGet package caching. We also have the ability to, one of those layers can be a runtime. So we can use a custom runtime. Now, we use custom runtimes you can basically use a custom runtime API to create support for things that we don't support in AWS. Things like PHP. We don't have support for Lambda. So someone has implemented a custom Lambda runtime API for PHP and allows you to run then PHP inside of Lambda. Well, .NET and even PowerShell are both supported by AWS. So we don't need to create things for those. But what we could do is we could support a version of .NET that isn't currently available, like .NET Core 3 or .NET 5 when it finally comes out. So to do that, we're going to use a thing called custom runtime inside of Visual Studio to create a custom. What am I going to do? Yeah, to create a custom project, we're going to use a custom runtime. So I'm going to search for AWS. I'm going to choose a .NET Core Lambda project. And in the blueprint, I'm going to choose, when it comes up in a second, I'm going to choose I'm going to choose custom runtime function. And what that's going to do, it's pretty similar to the empty blueprint that I used earlier, but it just has a slightly different execution model. So instead of coming into a function handler, it comes into a function called main. And what we do there is we wrap that in our execution environment, and then we call a function. We call the function handler. So this bit of the code here is identical to the other basic empty function that you saw earlier. So what I'll do is paste some code which only works in C#8. This is .NET 3, .NET Core 3. It's called a tuple switch. It's a new feature in C#8. It's able to switch on a tuple. So a parameter comes in, a first and second value, and then we're able to do a switch based upon those two things. So I can implement a game of rock, paper, scissors pretty easily with that. What I'm going to do is switch my project to .NET Core 3, a framework which Lambda does not support by default. And then I'm going to change my version of my application to remove that one line which says use latest language. And then hopefully the red squiggle should go away. They do. And then down here, I'm going to change the framework to .NET Core 3. So now my function is no real red squiggly. So in the function handler, what I'm going to do is just call this rock, paper, scissors function. It requires two parameters. Those two parameters are what gets switched on. So the first parameter is player1. I'm just going to take a string input to this lambda function, and I'm going to split that string by a comma. So some variable is going to come in. That's going to be my object. I'm going to split it by a comma. And then I'm going to pass one parameter to the first input and one parameter to the second input of rock, paper, scissors. And then hopefully it will go through that tuple switch, that new C#8 feature. And I'll be able to pass a string value with two variables into it, and it will play the game. So it's the same sort of principle. We press next. It's identical that we have to give it an IAM role to execute against. We upload that. It will take longer to upload. We're compiling against a runtime, a new runtime. It's going to have to actually package .NET Core 3 as well. So it's a little bit more complicated. But then, once it's updated, we should be able to go over here and just pass in a variable, which is a string, which contains rock, comma, paper. Invoke that. And the response back will be rock is covered by paper, paper wins. And I could try another one, paper and rock, invoke that, paper covers rock, paper wins. So we've implemented .NET Core 3 in Lambda using custom runtimes. Just quickly, I wanted to quickly show this demo. I'm probably going to run out of time, but we'll give it a shot. This is recognition. Recognition it's an AWS service, allows you to take upload an image, and it will label that image. It can do other things like celebrity recognition, image moderation. But in the toilet today, I found this weird little shelf for a mobile phone. I've never seen one of those. That's a very Ukrainian thing. I've never seen this. This is a new invention. I quite like it, but it's weird. So I took a picture of that, and then I uploaded it to recognition. And what it's done is it's labeled what it's seen in the image. So it's found it's indoors, it's a room, it's a bathroom, it's a toilet. Okay? Well, what if I want to build a lambda which could event? When I upload an image to S3, it's going to add this, it's going to basically look through the lambda. Now, if I don't get a chance to show this, I've got a recording of it, of this demo, which you can look at it later. But I'll try and finish this really, really quickly. So I'm going to build a function. I'm not going to actually show you that. I'm just going to show you what the code does. And in the function, what it does is it will, anything gets uploaded to a bucket, an S3 bucket, an image, it's going to run through this lambda function and run this C# code. It's going to check that it's an image. And then if it's an image, it's going to call recognition. And what I want to show you here is you can call any AWS service from a Lambda function. So it's going to call recognition with that image, which is uploaded to S3. It's going to find all of the labels on that image, and then it's going to write the labels back to that S3 image. And then it's going to attach it as tags to the S3 image, which we've uploaded. So what I'll need to do is create a new S3 bucket. So I'll create a bucket, which is where I'm going to upload my image to. So a bucket for the Beebs. I'm again doing this from all within Visual Studio. I've created a function which has that code in it, which takes the image and calls recognition and detects the labels. I add S3 as my source type for that event. Again, all from within Visual Studio. So now anything that I upload to the S3 bucket is going to trigger that function. So now if I go into S3, I can, from within Visual Studio, upload my image. There's no tags on that image. Okay. Now it's executed the Lambda function. It's added the tags to the image. So now if I look at the properties, you'll see human, art, candle, fire, people, vigil, and it found a coffee cup in the image. And this is the image that I sent up. It's of Game of Thrones where they left the coffee cup in the image. So I've used S3 recognition and Lambda in .NET to demonstrate you can call any AWS service from within Lambda, and you can call any AWS service from .NET as well. All of the documentation for .NET is on our GitHub page, github.com/AWS/.NET. Sorry I've rushed and I've run out of a little bit of time, but if you've got any questions, then please do contact me. I'm at @thebeebs on Twitter. I'm mbeeby@amazon.com on email. If you've liked the session, if you thought it was interesting, if you got something from it, please tweet me at @thebeebs. If you hated the session, if you thought I was terrible, if you thought this was the worst session of the event, please email me at mbeeby@amazon.com. Thank you very much.